Right, good afternoon, everyone. How was lunch? Was it good? Okay, so yeah, I'm just going to share a little bit about the semiconductor industry, but more specifically, this renaissance that we are in, as well as I'm taking an example of the metaverse. Okay, just a bit of an introduction here, but we'll look at the metaverse as a case study as to why design in chips is important and how it differentiates how companies do or competitiveness in certain companies and why some are more successful than others. So let's talk a bit about the industry. It's a growing one, and that's one big important factor. In the next decade, we're expecting the industry to grow. In fact, by 2030, we're expecting it to be a $1 trillion company. And I think most of you would know in the last 2 years have been spectacular growth in the industry. It's also been called the new oil. So, you see different countries vying for position in this industry. You hear a lot about China and US competing and how, they're playing different games, right? So it actually just goes to show how important it is and what a big impact it has on a country's ability to generate wealth and be successful. Okay, so the Renaissance, why we call it that is, we know that these things come in cycles, right? The semiconductor industry was in a cyclical industry, so there are ups and downs. We were in an up cycle, now it's kind of slowed down a bit, but just like it has happened in many years before, it would be up again, right? If we look at the investments, they've been huge in the last couple of years. So these are some of the recent headlines you would see. I think a very significant one for Singapore in particular was a $5 billion fab investment from Global Foundries. And then TSMC is building some of these big fabs in the US, in Arizona. A lot of it to serve big customers like Apple. And then more recently, the SIA, which is the Semiconductor Industry Association in the US, was calling for a lot more investment, up to $500 billion in the new, in more capacity. Okay, so why are we in this renaissance, right? And it's really driven by demand. So demand for all sorts of things. A big one, obviously, is in AI. And machine learning. And this, when we spoke about it at the panel just now, it's just got so much impact across so many aspects of our lives and in so many different technologies. And if you think about how AI works, you always need chips to power it. So that's one big factor. And then, of course, the other thing is how cars are evolving, right? So the number of chips going to cars are just accelerating a lot. For example, just from 2019 to 2025, we're expecting the number of chips in a car to double. So you're talking about 6 years, the number of chips is times 2. That's pretty amazing. And it's mainly driven by EVs, right, and the uptake of EVs. And then the other thing is how technologies are now jumping from one industry to another. So for example, in the last 2 decades or maybe decade, we've enjoyed the technologies from our handphones, smartphones in particular, and tablets, right? So these are technologies that give you power on the move, mobility. You got good batteries, you got nice screens, multimedia capability. But then now we are starting to take some of those technologies and going into other devices like AR, VR headsets, for example. So that's going to drive a new demand in a different industry now, or even a new capability, right? So then that's going to call for even more needs for better chips, faster chips, and so on. So we'll look a bit into that later when we look at the metaverse. And then one thing that's actually happened in the last 10 years was a lot of companies that were traditionally not semiconductor companies, right? Like software companies. So companies like Apple, which were making devices, now make their own chips. They design their own chips. Companies like Facebook, Google, Meta is Facebook. Basically, they're all making chips. not making them, but they design their chips and then they go to TSMC and get them made, right? Or some of the other fab partners. So that's driven a whole lot of new innovation because it looks like these companies are wanting the chips to differentiate themselves, give them a competitive advantage, and therefore driving to their own designs so that they can differentiate and have a leg up on their competitor. And that's also driving a big new impetus to invest in the semiconductor industry. Okay, so let's look at the metaverse. And I think this one is quite an interesting example of what's happening now, right? So if we look at what we need to power the metaverse, which is your AR, let's take, for example, a VR goggle, right? It's going to be portable, it's going to be sitting on your head. So it doesn't have to be super powerful, right? It just has, the screen it is powering is not that big, right? But more importantly, it needs to not burn too much power. It needs to be reasonably, doesn't have to produce a lot of heat. It shouldn't produce a lot of heat, otherwise your head gets really hot, right? It has to drive good graphics, right, and immersive experiences. But then it has to also incorporate other things like, accelerometers, gyroscopes, things like that, because it has to include your movement and giving you that feedback. And then in all, it wants you to have good battery life, so it has to burn as little power as possible. So all that in one device or in one system. So you look at who are the major players. Okay, so Apple talked about it coming out with a VR headset. We know Microsoft and Meta, they've already done it, and there's actually other companies like Magic Leap that are doing it as well. And we can look a little bit about why maybe certain companies have an advantage here, actually because of their power or their capability in making chips or designing chips, right? And I think we'll look at two, which is one is Apple and what Meta is doing. Okay, so the battle here is between Apple and Facebook or Meta. And in a Bloomberg article last year, it actually quite boldly said that they think Apple will win this race. And they cited a few reasons why that's the case. One of the key ones is that Apple has a big advantage in terms of semiconductors, in terms of chips. It's very much more design focused in terms of hardware. And it's already got a big ecosystem that's ready, right, with the necessary software and OS and operating systems. And surprisingly, I mean, maybe not surprisingly, Apple has been doing silicon for quite a few years now, right? Since 2008, in fact. Even after the first iPhone launched, the next version of the iPhones already started having their own silicon. And they are a big customer of TSMC. So let's look a little bit in detail, because this slide is a little bit busy, but it helps us understand why Apple has this big advantage. If you think about all the things that Apple, I mean, how many Apple fans here? How many of you use Apple products? So you know Apple has the phone, it's got the headset, right? It's got iPad, of course, the tablets and all that. And in fact, now more than before, a lot of their own chips are going to all these, right? So I know we're familiar with the chips that go into their handphones, for example, the A series chips. Then you have the M series, which is at their laptops. But they also have some of these other chips that maybe are not so well known. So like the S series, which is used for head tracking. So it's got accelerometers and all that. I think that's in their wireless headsets. They have a radio chip that's used to communicate wirelessly. They send your music to your headsets, right? To the wireless headsets. And all these are actually world-class in terms of power, efficiency, and performance. So if you think about in terms of an ecosystem, Apple already has pretty much everything it needs to make a really compelling and very powerful VR headset. And these are chips that it developed itself, so it all works together. They probably planned this out before because they knew they were going to go to this business at some point. And if you compare with what Meta has, besides, okay, maybe Meta can create one chip of its own, but it has to buy chips from all the other people, right? Like Qualcomm, Intel, and NXP. And then figuring out how to make all this work together, okay? And Apple kind of already has it all figured out, right? So you can see why Apple has this big advantage. And then if you think about what gave Apple this capability, is because it designed its own chips. So the design part became the big differentiator. It's going to be a lot more investment in design. The trade groups are calling for up to $30 billion of additional incentives to encourage the design industry in the US. And in fact, Forbes had an article that talked about how design was actually the most value-add aspect of the semiconductor industry in terms of value added. And there's been a lot of startups as well. So that was the other thing that came out from the last 2 years, that there was a lot more investment in startups which just did chip design. So we know this design is important and it's an exciting field in the semiconductor industry. So for the students here, you might be asking yourself this question: is it for me? And should I embark on a career? So maybe I'll share a bit about some of the things that are interesting or maybe important about being in this career, right? So let's maybe ask why first. Why would you want to have a career in IC design? So for sure, what you will have is you will gain a really good understanding of what all these different complex systems do, because the chip is usually the heart and the brains of the system. So if you design the chip, it gives you an understanding of what the rest of the system is going to be doing. But industry is obviously dynamic, and semiconductor industry in general is a very dynamic one. It's very fast moving, and there are a lot of new innovations and new improvements coming along all the time. And you can be a part of this renaissance, right? This big new investment coming in, and how chips are going to really be powering the future of society, basically. And then some of the skills that you will pick up as a designer, right? So typically, when you do IC design, you are actually working on quite big databases, because chips these days are complex. So time and resource management would definitely be one aspect. You have to be an analytical thinker, because a lot of what you're doing is reasonably complex, and there'll be problems that you have to solve, so you have to learn how to do that. There's a lot of room for innovation. So, new ideas and how you also articulate those ideas. How do you share those ideas with your team members? And how do you convince your boss that this idea is a good one, right? And then, of course, the coding and scripting and all the usual, what typically a designer does when it's manipulating the databases to get a chip out. And that's it. Thank you for your attention. And I hope you will be interested in finding out more. You can always visit our booth at AMD outside. Thank you.
Thank you, Eugene, for sharing. Please hold on. We do have some questions for you on Slido. But meanwhile, while we're answering your questions, you may feel free to add on your questions as well. So what does Metaverse relate to chips? How does Metaverse relate to chips?
Well, so the Metaverse is something that was coined by Facebook, right? Because they call themselves Meta, and then when you put on your VR headset, you're in a different world, so you're in a Metaverse. But actually, how it relates to chips is how it's being powered, right? What enables this VR headset and all the nice graphics and the sound and the immersion that you get by being in the Metaverse. It has to be powered by some hardware, and that hardware is basically chips, right? All working together to give you that experience.
I see. Yep. I see. Now we have a better understanding for sure. For people like myself, I might not be too sure as well. So what skills do I need to work with chips?
Well, as a designer, if you're going to design chips, I would say your electrical engineering degree would be the first thing. A good foundation in physics, mathematics would be very helpful. And then yeah, you'll pick up if you did a degree in engineering, electrical or electronics engineering in university, that would cover most of it, at least for a start. And then the rest you'll pick up when you start work.
A lot to learn on the job.
Yeah,
And
quite a
the,
bit of on-the-job training and learning. Yeah.
okay, cool. So next question from Michael Jackson. What are the difference between your company and the others?
Wow.
Wow.
Wow, that's
How
that's
does
a,
your
that's a
company
very broad
stands out?
question. I don't know how many of you are familiar with AMD then? Okay, so AMD is actually quite interesting. If you understand what AMD does, we do CPUs, right? And we do GPUs. So GPUs is graphics processing. So we do general processing, which is CPU, and graphics processing, GPU. And we also, after purchasing Xilinx, so Xilinx is now part of AMD, we also do FPGAs. And we are pretty much world-class in all three, right? I think most people would accept that AMD may not be the biggest company or have the biggest market share in all three, but we are there or thereabouts, right? And I think that's the only company currently that can claim that status, actually. So, for example, Intel is a CPU company, and they just got into the GPU again, but it's early stages for them. So we're definitely ahead of Intel in GPUs. And they have FPGAs, but we're ahead of them in FPGAs also. So if you want to work for a company that is close to being a leader in all three, AMD is kind of the one.